Welcome to the deep dive. Today, we're jumping right into the really fascinating story of Maya blue.
Ah, yes, Maya blue. It's an amazing pigment, isn't it, from the ancient Maya?
Absolutely extraordinary. When you think about it, the color, it's like capturing the color of a perfect blue sky.
Exactly. And they use it everywhere on pottery, sculptures. You see it in murals, their books, the codices.
And even rather somberly in sacrificial rituals, right?
That's right. But what makes it really special, I think, isn't just the color, beautiful as it is, it's the chemistry.
The chemistry. Okay, tell me more.
Well, it's this incredibly stable chemical hybrid, basically organic indigo, that gives the blue bonded with an inorganic clay, palygorskite.
Palygorskite. Okay, and that mix makes it tough.
Super tough. That's the key to why it lasts so long. It just resists fading, even in those, really harsh tropical conditions the Maya lived in.
Right, so we're not talking about some paint that just washes away. This stuff endures. How far back are we talking?
We're looking at the late pre-classic period for the earliest finds, so around 300 BC to maybe AD 300.
Wow.
Yeah, first spotted down at Calakmul in southern Mexico. And from there, it spread across Mesoamerica, used for over 1,700 years.
17 centuries. That's incredible longevity for a specific color technology.
It really is.
So for this deep dive, we really want to explore the mysteries around how they actually made Maya blue.
Yeah.
Because there's new information, right?
Exactly. There's been a recent discovery suggesting a second way they produced it, a previously unknown method.
And this comes from Dean E. Arnold's new book.
That's the one, Maya Blue, Unlocking the Mysteries of an Ancient Pigment. Just came out December 2024 from University Press of Colorado. It pulls everything together.
Okay, good timing for our listeners then, because the whole story of figuring out Maya blue has been a long one, hasn't it?
Oh, absolutely. I mean, it was first identified way back in 1931 at Chichén Itzá. But what it was, chemically speaking, that was a puzzle for decades.
Right, until around 2008, things started becoming clearer.
Yes, 2008 was a first sort of major breakthrough in understanding the composition.
So let's talk about that first discovery. How did they figure out that initial recipe, as it were?
Well, it's a fascinating story, actually. The team, led by Dean Arnold again, they analyzed these tiny, tiny traces of pigment
From where?
from pottery fragments found at the bottom of the sacred cenote, the well at Chichén Itzá.
Ah, the sacrificial well. Okay.
Exactly. And by looking really closely, microscopically, they figured out that first method, it involved heating.
Heating what specifically?
A mixture, indigo, for the blue color, obviously, then copal, the sacred incense they used,
Right, copal.
and that clay mineral, palygorskite. They heated this mix over a fire.
Okay, so indigo, copal, palygorskite, plus heat. That was recipe number one. Seems pretty specific.
It does. Very intentional, almost like a ritual process in itself, maybe.
But now it seems that wasn't the only way. Tell us about this new discovery, this second method.
Yeah, this is where it gets really interesting. Just this past April, Dean Arnold presented findings about a second method at the Society for American Archaeology meeting.
Okay.
And it's all laid out in detail in that new book, of course.
So how did he stumble onto this second method? You mentioned detective work earlier.
You could definitely call it that. It was almost like a Sherlock Holmes investigation, as he puts it. He examined about a dozen Maya bowls, also from Chichén Itzá, very, very, very carefully.
Right, scrutinizing the details. What kind of clues was he looking for on these bowls?
Well, he found several key things. First, there was this white residue inside the bowls,
Okay.
which they identified as palygorskite, the clay, and it looked like it had been ground when wet, leaving traces in tiny cracks from the grinding tools.
Oh, interesting. What else?
Then, microscopically, they found these little burnt bits of plant stems.
Burnt stems.
Yeah. And maybe the biggest clue, the bases of the bowl showed clear signs of being heated from underneath.
Okay, so palygorskite residue, burnt plant stems, and heating from below. But crucially, no obvious sign of copal this time.
Exactly. That seems to be the key difference. These clues together strongly suggest a second way to make Maya blue, one that seems to leave out the copal incense entirely.
So they could achieve that same stable blue just by heating indigo and palygorskite, maybe with these specific plants involved, but without the copal.
It certainly looks that way. Heating the indigo source and the clay, maybe with whatever plant material those stems came from, that seems to have been enough in these cases.
That's really fascinating. It implies maybe more flexibility in their techniques than we thought.
I think so. Maybe they adapted based on what they had available, or perhaps, the specific use intended for the pigment. It wasn't just one fixed recipe.
It really underlines how important this color was, doesn't it? It wasn't just decoration.
Absolutely. Dean Arnold calls its invention a genius discovery, and he suggests the knowledge of how to make it was probably quite specialized, maybe limited to priests or other experts.
That makes sense for something so culturally significant and maybe technically complex. And it did have symbolic meaning, didn't it? Particularly with religion.
Yes, definitely. It seems strongly linked to Chak, the Maya rain god, especially in offerings during droughts.
Sacrifices to bring rain?
That seems to be the connection. Arnold even speculated, relating to that first method with copal, that the heated mixture itself might have been seen as a kind of incarnation of the rain god Chak.
Wow. So the pigment itself embodied the god they were appealing to. That's powerful.
It really shows how deeply intertwined color, ritual, and their worldview were.
Now, even with this second method discovered, you mentioned the mystery isn't completely solved. What's still being investigated?
Well, a big question now revolves around those burnt plant stems found in the bowls.
Right. What kind of plant was it?
Exactly. Researchers are doing microscopic analysis trying to identify the specific genus, maybe even the species, that provided the blue in this second copal-free method.
Figuring that out could tell us even more about their botanical knowledge, couldn't it?
For sure. It's another layer of their understanding of the natural world.
And regardless of how it was made, that stability is just incredible. Let's just circle back to why it lasts so well.
It all comes down to that unique chemical bond we talked about. The indigo molecule gets trapped, you could say, within the structure of the palygorskite clay when heated.
Like locking it in place.
Sort of, yeah. It protects the indigo. So unlike regular indigo dye, which would fade or degrade, Maya blue just holds its color for centuries. It's remarkably resistant. Acids, alkalis, solvents, they barely touch it.
That's amazing for a natural pigment. A testament to their ingenuity.
Absolutely. And remember, this wasn't just a local thing. It was used widely.
Right. Across Mesoamerica for that whole 1700-year span we mentioned.
Yeah, you find it on all sorts of artifacts in different places over that huge stretch of time. It clearly had enduring appeal and importance.
So for anyone listening who's now completely hooked on Maya blue,
which is understandable,
it sounds like Dean Arnold's new book is really the place to go for the full story.
Definitely. The reviews really highlight that. Laura Osorio-Senex mentions it's the most in-depth look at the research history and its cultural connections.
And Leslie Cecil points out how Arnold brings all the research together, past and present, in a way that's really accessible.
Yeah, accessible even if you're not, a specialist in Maya archaeology or chemistry.
So, Maya blue. It's just a fantastic example of ancient Maya skill. Artistic, yes, but also chemical, technological, deeply tied to their knowledge of the world.
It really is. It makes you think, doesn't it? What other seemingly simple materials from the past might hold these kinds of complex scientific and cultural secrets?
That's a great point.
And, what can the story of something like Maya blue teach us today about how technology, culture, and belief systems can be so closely interwoven?
A really fascinating question to ponder. So, if this deep dive has sparked your interest, we definitely recommend checking out Dean E. Arnold's book, Maya Blue, Unlocking the Mysteries of an Ancient Pigment.
Published by the University Press of Colorado, 2024.
And good news for accessibility, too. The ebook version is set to become open access eventually through the Path to Open program.
Which is great, making the research widely available.
Absolutely. Well, thanks for joining us on the Deep Dive.